Okay, for part D, we need to work out which ones have angles of 50 degrees. Well, this is a right angle, which is 90, and 90 take away 40 is 50, so A is good. This is a straight line. Angles on a straight line add up to 180, and 180 take away 65, take away 35, it's definitely not 50. 180 minus 65 minus 35 is 80. So it can't be B. And for C, here we've got a triangle. Angles in a triangle add up to 180. So far we've got 65 plus 65, which is 130. And 180 take away 130 is 50. So C is 50. So the answer here is A and C. So tick for A and a tick for C there. Okay, question E. So we want to work out the area of the centre circle in square metres. The formula for the area of a circle is pi r squared. If the diameter is 0.9, then the radius is half of that, so 0.45, and that is centimetres. Now, it makes sense here to turn this, well, first of all, let's scale this up. So in real life, it's 400 times greater, so 0.45 multiplied by 400 is 180 centimetres. And this is what I was on the verge of saying a moment ago. Since we want the area in metres squared, if I use 180, I'll have the area in centimetres squared. So it makes sense to turn this into metres. So there are 100 centimetres in a metre. So 180 centimetres is 1.8 metres. So the calculation is now 3.14 multiplied by 1.8 multiplied by 1.8. So grab your calculator, 3.14 times 1.8 squared, or 1.8 times 1.8, and we get 10.1736. That's not a ridiculous number of decimal places, so I will include the lot, 1736 square metres. Okay, question F. Okay, so the key sentence here is the coach chooses a forward at random. So we're only interested in the forwards. So out of these forwards, and now how many forwards are there? Well, there are 8 in total. Out of the 8, how many are over 1.8 metres tall? Well, that is 3. So that is the probability, 3/8, and that is the answer, obviously, as a fraction. Now, to turn the fraction into a decimal, remember that this line here means divide, and 3 divided by 8 is 0.375. So to turn a fraction to a decimal, remember, just divide the top by the bottom, so 0.375. Okay, let's move on. A player's true shooting percentage, TS percent for a game, is calculated using the following formula. So we need to calculate it for Lottie for this game using this information here. So the percentage is going to be 50p, so that means 50 times by p. P is the total points scored, which is 15, divided by 0.44f, which means 0.44 times by f, and f is the number of free throw attempts, which is 8, plus a, and a is the number of other goal attempts, which is 17. So if you've got a fancy calculator, you can just type it in exactly as it looks, but you might want to break this down in bit by bit. So 50 times by 15, that is 750. Be careful with the bid mass here, we need to do the 0.44 times by 8 first, and that is 3.52 plus 17. So that will now be 750 on the top and 20.52 on the bottom. So if you prefer, just type this fraction with just one number top and bottom, or 750 divided by 20.52 will also work, and that will give us 36.5497. Is it telling us how it wants the answer? It isn't, so we can just simply round that to well, whatever we want really. Let's just round it to one decimal place, so we'll call that 36.5%, although I'm sure 37% would also be accepted in the mark scheme. Here are the video solutions for NCFE Level 2 Functional Skills Maths. This is Section B, which is the calculator section, and this is from February 2020. Okay, so let's take a look at question number 2. So we need to know what percentage of her shots go in the basket. Well, we know she takes 75 and 33 go in, so let's write that as a fraction. That is 33 out of 75. Now to turn a fraction into a percentage, it's top divided by bottom. Remember, this line of a fraction means divide, multiplied by 100, and 33 divided by 75 multiplied by 100 is 44, so the answer is 44%. Question number 2. This question is quite confusing, but the first thing we need to do is work out the median for games 7 to 12. So the first thing we need to do is put them in order. So we've got 6, we've got a 6, 2 10s, a 12 and a 14. Now the median is the one in the middle, so to find the middle, chop one off the left, chop one off the right. Do that again until we've got either 1 or 2 in the middle. Here we've got 2 in the middle because we've got an even number of values. So the median is the halfway point between 10 and 10. Well, that is nice and easy. That is still 10. So the median is 10. Now we need to be careful here. The median for these games is 25% higher than her median for games 1 to 6. Now we don't know what that is for games 1 to 6. We don't have any information on games 1 to 6. So what this means is that the previous median, the previous median. Now when you increase, what was it increased by? Did it say 25%? Now to calculate 25% of an amount, you would use the multiplier 0.25. This is the decimal equivalent of 25%. It's 25 divided by 100. So multiply by this number to work out 25% of an amount. But if you want to increase by 25%, you add 1 to this value. So that would be 1.25. So the previous median would have been multiplied by 1.25 to give us this new median of 10. So if the previous median times 1.25 is 10, then PM, the previous median, is 10 divided by 1.25. So therefore the previous median was 8. Okay, so what we need to do now is work out how many of these games did she score greater than 8. Well, that is 1, 2, 3, 4 games. So what that means is this £50 is going to be increased by 20% 4 times. So let's just make a note of that. So the £50 increases by 20% 4 times. Now to increase by 20%, well, what is our multiplier? Well, 25% we used 1.25, so 20% we'll use 1.20, or just 1.2. So the calculation is 50 multiplied by 1.2 4 times, so we can just take a shortcut and apply to the power of 4. And 50 times 1.2 to the power of 4 is 103.68. There we go, so that is our final answer, £103 and 68p. Okay, moving on to activity 3, question 3. So it says here, what fraction of the drivers over 60 can read a sign at over 400 feet? Well, first of all, how many drivers are there over 65? So here we have the cutoff point for 65, and how many drivers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 drivers over 65, and how many can read a sign which is more than 400 feet away? So this is 400 feet here. So how many are above this line? Well, we can see there are 3. So that is 3 out of the 12, and 3 out of 12 we can divide the top and the bottom by 3, so that simplifies down to 1/4. Okay, so part B. Using the scattergram, I predict that between the ages of 25 and 65, the maximum distance at which people can read a sign reduces by over 50 metres. So 25 and 65. Well, first of all, let's just get rid of all the workings from the previous question. Okay, so it's 25 and 65. So I can see that for a 25-year-old, that is 500 feet. Oops, that should be a T. But for 65, we don't have a reading. So what I'm going to do is I am going to put in a line of best fit. So a line that cuts right through the data, trying to keep the same number of data points on either side of the line, so that this would be a very bad line of best fit, as would this. So sort of through the middle, like something like that. That should be fine. It's a sort of thing where if I asked 10 people to do it, they would have 10 different lines, but all might be perfectly acceptable. Okay, so now I need to take a reading for 65. So for 65, I'm going up. This is how you get your marks, just demonstrating that you know how to use a line of best fit. So for me, it's 2 lines down. Again, if you're using a ruler as well, this is a lot easier. So I'm going to say for 65, it's 360 feet. So what is the difference between 500 and 360 feet? 500 take away 360 is 140 feet. Now, if 1 metre equals 3.28 feet, that means to go from metres to feet, I'm multiplying by 3.28. So if I'm converting feet back to metres, I'm dividing by 3.28. So 140 divided by 3.28 comes to what? That gives us a total of 42.68 metres. And what was the question say? Is Jed's prediction reasonable? No, Jed is incorrect, as the distance is only 42.68 metres, which is less than his prediction of 50 metres, or words to that effect. Not sure how you're supposed to fill that in such a small answer box, but there we go. It's the numbers that are the important thing there. Okay, so we want to work out an estimate for the mean speed. So we've got 4% of the cars travelled between 40 and 50 miles an hour. Well, that's a bit annoying. Because we don't know exactly how fast they have been. So rather than worrying about this as a percentage of cars, let's just say that there were 100 cars and 4 cars travelled between these two speeds. They might have all been travelling at 40 or maybe 49.9. So what do? We're just going to make a guess that they all travelled at 45. So I'm going to make a column here called the midpoint. Now if we've got 4 cars travelling at a total speed, we've got 4 cars travelling at 45 miles per hour, then that is a total of 4 times 45, which is 180. Now, so what we've got here, normally this is labelled as the frequency column. And when you're working at an estimate for the mean, when you're dealing with grouped frequencies, then some people know to automatically do midpoint and then frequency times midpoint. But it does help if you can understand why. So the reason we're working out a midpoint is we know that there are 13 cars that travel between 50 and 60. We don't know their speed, so we're assuming that they all travelled at 55, and 13 times by 55 is 715. Here the midpoint is 65, and here the midpoint is 80. And again, we're just multiplying these two columns to get 2340 and 3760. Now we know that these add up to 100. It does say percentage, so if you accidentally add them, you'll see they do add up to 100. And we also need to add up the frequency times midpoint column. So this is the total of all the speeds combined, or the estimated totals, I should say, 6995. So the estimate for the mean is this total divided by the number of cars. So 6995 divided by 100, and that is 69.95 miles per hour. Okay, moving on to D. Okay, so 1.1 L, that means 1.1 multiplied by L plus 9. So 1.1 times 30 plus 9. Remember, using BIDMAS, we need to do the 1.1 times 30 first. And 1.1 times by 30 is 33. And 33 plus 9 is 42. So the answer here is 42. Okay, so for this question we need to work out the mean for 2014 to 2016 and separately work out the mean for 2017 and 2018. So what I'm going to do is I'm going to add these 3 numbers together, and if you add those together, you should get a total which is 4150,231. So therefore the mean is going to be 4150,231 divided by 3, and that comes to 1383410.333. If we add these two together, we get a total of 2859,415, and if I divide that by 2, I've got a mean of 1429707.5. Okay, so is this 3% higher than this value here? Well, what I'm going to do is I'm going to increase this value by 3%. Now 3%, the multiplier is 0.03, but for a 3% increase, I add 1 to that number, 1.03. So what I'm going to do is, let me just copy that number, I'm going to multiply 1383410.333 by 1.03, and I get 1424912. Jed says that the mean number for 2017 and 2018 is over 3% higher. So this is 3% higher. Is this greater than that? We've got 1429, 1424. So yes, Jed is correct. Okay, activity 4 and question 4a. Okay, so what we need to do here, first of all, is we know that we can get an average of 3.9 words per square centimetre. So what is the area here? Now the key thing is there's a 2 centimetre margin around this piece of paper. So what this means is there's a gap here of 2 centimetres and 2 centimetres, 2 centimetres here and 2 centimetres here. So we need to be careful here because a lot of people will just simply subtract 2 centimetres from 20 and from 13, but we actually need to subtract 2 plus 2. We need to take 4 from 13. So 13 take away 4 is 9. So this is 9 centimetres from here to here. And if we subtract another 4 from the 20, then this is 16 centimetres from top to bottom. So the dimensions of the text is 16 times by 9. So 16 centimetres times 9 centimetres, 144 square centimetres. So what we need to do is, if we can get 3.9 words for 1 square centimetre, so if we've got 144 square centimetres, then we're going to get 3.9 times by 144, which is a total of 561.6 words per page. Now, if we've got 2,000 words in total, how many pages do we need? Well, how many 561.6s go into 2,000? In other words, what is 2,000 divided by 561.6? The answer is 3.5. So 3 pages is not going to be enough, so we will therefore need 4 pages. So we're always going to have to round up here. So 4 pages. Okay, part B. I must admit I overthought part B for a long time and thought there was information missing. It's only a 1 mark question, so there's not much work that needs to be done here. What is the maximum number of printed pages the leaflet can have? It doesn't really make sense because a leaflet doesn't really have pages in my opinion. Anyway, so we've got 1 here, 2, we've got a 3rd one round the back, we've got a 4th on the back of number 1, a 5th on the back of number 2, and this one that is grey is 6, a total of 6 pages in inverted commas. I thought that was a bit of a silly question, that one, but as I say, it's only 1 mark. 4C, people will struggle with this one because they were like, well, how much is a box of leaflets? So what you could do, this is not how they do it in the mark scheme, but for me this is trying to get inside your head. This is probably going to be the easier way to work it out. Let's say 1 box costs £100. Nice, give yourself a nice easy number. Don't say a box is £67.32. So if you're in offer A, you're buying 2 boxes and get the 3rd half price, so that's 100 plus 100 plus 50, so that is 250. Offer B, so the 3 boxes would be 300, and 5% off means you pay 95%. So what is 95% of £300? Now, multiplier for 95% is 0.95 times 300. It's the decimal equivalent of 95%. It's this number here divided by 100, and 0.95 times by 300 is £285. So we can see that £250 is substantially less than 285. So therefore, offer A is the best answer. Okay, for part D, the first thing we need to do is work out the median. Now, for the median, we need to put these in order. So, I'm going to put them in ascending order. It's much easier than descending order. So the lowest is 45, and we've got a second 45, and I would recommend just chopping them off here. Otherwise, you might miss a value. Okay, the next is, I believe, 125, 129. Anything in the 130s, we've got a 132, 138. Anything in the 140s, we've got a 146, 148. Then it's 180, 182. And then it's a bit annoying, I like to keep them on one line, it makes the next job a bit easier. 195 and then 202. Have I got 12 values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, because there's an even number of values, so what I'm going to do now is I'm going to cross off from each side until I expose one or two numbers in the middle. Now, because I've got an even number of values, I'm going to get two in the middle. So chop off one on the left and on the right. Do the same again. Repeat the process. Keep going. And we've got two in the middle. So the median is the halfway point between these two values. That's not immediately obvious, so what we can do is add the two values together and then divide by 2. 138 plus 146 is 284. 284 divided by 2 is 142. So the median is, let's write down here, the median is 142. Okay. Okay, that wasn't the answer that needs to go in the answer box, but anyway, we do need to know the median. So I'll just make a note here that this is the median. So secondly, what is the mode? Which value occurs the most commonly? And that is 45. So the mode is 45. So we have a median 142 and a mode of 45. So both of these are valid ways to calculate an average. We could also calculate the mean, but the question's not asking about the mean. And the question is, why is the median better than the mode? Well, the mode is not a very good value to use here because it only repeats twice. There's no other number that repeats twice, and also 45 is the lowest value. It just so happens it repeats twice, and so therefore is the most frequent value. It's not like there are 20 45s and 13 125s and 6 138s, which would be a bit more valid. All of these numbers appear only once, apart from 45, which appears twice. And again, because even if it wasn't the lowest, that would still be a fairly poor use of the mode because it appears twice, not once. But in this particular example, it's even worse to go with the mode because it happens to be the lowest value, so it's a bit of a fake average in this case. So why is the median better for her to use? Well, it's because the mode appears only twice, and the mode is actually the smallest value, or the lowest value. Okay, so 4E, the company's income in 2019 was this, and this was higher than 2018. So the 2018 income was increased by 7%. Now, 7%, the multiplier for 7% is 0.07. As mentioned before, this is the decimal equivalent of 7%. Rather. Now, for a 7% increase, we would add 1 to this number. So that gives us 1.07. So the 2018 income was multiplied by 1.07 to give us this new value of 863490. So if we want to work out this value, what do? Well, we know we multiplied by 1.07 to get this, so therefore the 2018 income must be 863490 divided by 1.07, and 863490 divided by 1.07 is 807000. And if you want to check your answer, multiply that by 1.07 and you'll see you get back to the original 863490. Question 4F, this is a difficult ratio question. So we know that 2 11ths are white, so therefore 9/11ths are not white. And 1/3 of this are black. So what is 1/3 of 9/11ths? So remember, of means times. So 1 times 9 is 9, 3 times 11 is 33, and this fraction can be simplified. Divide top and bottom by 3. We have 3, we have 11. So 2/11ths are white, 3/11ths are black, so that is a ratio of 2 to 3. And that is the end of the section.